Hello, today I'm going to talk about inversions, which are transformations of the plane, like rotations or reflections, but it is a transformation more complicated that can transform a circle into a line and reciprocally a line into a circle, and that's what we will see today. So the definition of an inversion. So first an inversion needs a center that I will call O here, and a report K, which is K, and I will put it at 3. So OA is equal to 1, and the inversion is such as K is equal to OA times OA dash. So A dash OA dash is equal to K divided by OA. K is equal to 3, OA is equal to 1. So OA dash is equal to 3 divided by 1, which is 3. And you have to know that A dash, the inverse point, has to be on the ray OA, so the center and the point we want to inverse. So OA dash, A dash is approximately here, and let's have another point B of OB is equal to 1/2. So here is the same. If you understood well, OB times OB dash is equal to K, which means that OB is equal to OB dash, is equal to K, which is equal to 3 divided by OB, which is 1/2, and it gives us 6. So OB dash is equal to 6. B dash has to be on the ray OB, so OB is approximately here. B dash, is approximately here. So as you can see, the more you are near the center, the more the inverse point is far from the center. And now I will draw the line AB and try to inverse it. So as I said, the point near the center are inversed far from the center, and so reciprocally the point the farthest from the center is a point to infinity, and its reverse point is the center. So the nearest point to the center is the center. In fact, we can say that the inverse figure of the line AB is the circle which pass through the 3 points O, A dash, and B dash, which is approximately here. It's not a perfect circle, but you can see the idea. So that's an inversion. So as you can see, a line is inversed into a circle. So now I'm going to talk about polarisations, which look like inversions but are quite different. So a polarization needs a center and a circle, a center of the circle, in fact. So center O of the circle C, for example, and let's put the point A, and the transformed point A dash will be such as OA times OA dash is equal to the radius squared. So the radius of our circle C. So this equation looks like the equation of the inversion, but we're not with a k, but with a radius squared, but k replaced by radius squared. So it's the same. A dash will be on the ray OA. So OA, let's say R is equal to 1, OA is equal to 0.5 here to make it easier. It's not 0.5 here, but you understand. So 1 squared is 1 over 0.5 is equal to 2. So OA dash is equal to 2, A dash here. And I said that the polarization won't form a point into a line, and here you don't have any line. So in fact the line will be the perpendicular to the ray OA, which pass through A dash. So D, for example. So the polarization transform the point A into the line D. So this has many properties, but I will explain it later in other videos.